All right. So homework. Right? I think we got the right ones here. Okay. All right, so we're going to do our last two types today, right? So let's talk about these types that we did. We're going to kind of do a nice little list of all the types and what they look like. We're going to do the two new ones, and then we are having a quiz next week on all of these, okay? All right, so this first one. Right, this first one was what? An area problem, right? So it might be helpful to label which types are which. Remember, for your quiz, you can use notes, you can't use packet. Notes, yes, packets, no. Okay, number 2 is the three-sided one, right? 3 sides. And then 3 is a uniform width. You got to make sure you are always answering the question asked. So dimensions of the room, 16 by 25. What is this one? Dimensions of the piece of land, 160 by 20 or 80 by 40. How wide is the border? 2. So does anybody want me to go over any of those? Any of those that you want me to go over? Yeah. Yeah, right. I'll flip it to the next page in a second. 3. Okay, so 3. Right? So you got to read it and you got to decide, is it an inside or is it an outside? So a rectangular rug is to fit in a room so that the uniform width is left on all 4 sides. If the room is 12 by 14, right? So that is given outside, 12 by 14. And we know that the area of the rug is 80. So 80 is just that rectangle. So since we're given outside and I want to find inside, I got to use a subtract. Right? So when you're given outside, you're going to inside, it's subtract. When you're given inside, going outside, it's an add. So you guys can see, I just multiplied them all out. Brought that 80 over. Always try to reduce your numbers, right? I divided by 4 everywhere. So then you factor it, you get 2 answers, 11 and 2. The reason why 11 doesn't make sense, if I plug in 11 right there, I get 2 negative dimensions. Is that okay, Will? I know I'm not going step by step, but again, a lot of it is the setup. Do you understand the setup of the subtraction? Okay. Lloyd? Nope. Nope, you don't get negative dimensions. Nope, when I plug in 11, I get 12 minus 11 times 2, 22. So as soon as you do it right there, that's a negative 10. That's a negative dimension. That doesn't work, right? So the reason that 11 works is because both of them are negative, and negatives would cancel each other out to make an 80, but a negative 10 still doesn't make sense for the distance. Exactly. 11 is too big for the dimensions that I have. So then when I take 2 and I plug it in, 12 minus 4 is 8. That's okay. Plug a 2 in here. 14 minus 4 is 10. That's okay. So you're right. 11 is too big. Okay. So then the second page. Second page. This is the corner of the box one. And question was original dimensions. This one's another uniform width one. Question was width. So again, I didn't even put negative 30 there, right? And then this one is a Pythagorean. Did I put record or no? All right, so is there one on here that you guys want to go over? Triangle one. Yep. Okay, so triangle one. So it says longer leg is one longer than the short. So this is short. I'll make that X. That one's longer than it. So it says one more than the short. So that's our X plus 1. And it says hypotenuse, 8 more than the long. So if this is the long, 8 more than that is going to go plus 8. So that's why it's X plus 9. Okay. So again, you set up your picture first. So then this is where I told you guys you might make an error. X plus 1 all squared is X plus 1 times X plus 1. So you got to FOIL it out. X plus 9 all squared is X plus 9 times X plus 9. Whoa, where did that go? Easy. X plus 9 times X plus 9. And I got to FOIL that out. I'm going to try to get it back to the other screen. I don't know what it's doing. I'll figure it out in a second. There we go. Okay, so I FOIL those out. So then again, you always need your 0. So I'm bringing everything to that side. And then you just factor it. I can't have a negative X, right? I can't have a negative dimension. So 20 is the only answer. Is that okay, Lloyd? When it says, I'm actually going to do that in a second. I'm going to do all the types and what you're going to look for each type. Okay. Any other ones you guys want to look at? All right, so let me try to get it back to normal here. I don't know what I did. Let's try that. Nope. All right, I have no clue what I did. Did it somehow. All right, so again, notes you can use on your quiz, packet you cannot. So any notes that you can take are going to benefit you. So what I'm going to do first is we're going to recap the types, right? So I'm going to recap the types of problems, right? And how you can tell which one you're going to use. So again, you guys do need a calculator. So if you don't have a calculator, you are going to want to grab one. All right, so first type that we did an area problem. All right, so to me, that's the easiest type. You just really usually need one formula. It's area equals length times width. And usually you rewrite one dimension in terms of the other. Right? You rewrite one dimension in terms of the other. So that's the first type we did. Second type we did was an area and perimeter one. That one you usually write an equation that relates area and perimeter. So you're going to draw a picture. Always draw a picture in all of them. And plug in area and perimeter of picture. So like when you have a formula, you don't want two variables. So it usually says something like the length is 2 more than the width. So L would equal 2 plus W. So the length is written in the terms of W. Okay. All right. So to me, those are kind of two basic ones when you're just using area and perimeter. So now we got corner, we got uniform, we've got 3 sides. All right, so let's talk about uniform width. Yep. Yep. Okay, so uniform width is when you kind of have a border in your problem. So you're given, well, you're not given, you can draw 2 different pictures. So in both of these, the uniform width is kind of around here. I know I'm not writing that very well, right? But this is your uniform width. So think of like a picture frame. That's a good one for this one. An example of a picture frame. So we can be given 2 types. If I'm given inside dimensions, an L and a W. Then I'm going to use addition to get the outside dimensions. So addition is used for outside dimensions. The whole uniform width is X everywhere. So most likely it's going to be, whoops, didn't mean to go that high. Most likely it's going to be L plus 2X and W plus 2X. And again, L and W are usually numbers. Our second type is when we're given outside. So L, W, my X is the frame, right? My X is the frame. So that's when we're going to use subtraction for the inside dimensions. So we're going to go L minus 2X, W minus 2X. Are those 3 okay so far? All right, so which one's next? Corner of the box will be next. Corner of the box. So this is where you start with a rectangular piece of cardboard and you're cutting out squares. And it makes a picture that looks like that. Right? We cut out squares. So we usually start with L by W. So then my new dimensions are L minus 2 of the cutouts. My dimension is W minus 2 of the cutouts. And again, if I'm not using words that make sense to you, just let me know and we can try to change it. So then what ends up happening is we have a rectangular box, right? So I get a rectangular box that looks like, oops, I did it too far. That looks like that. And usually I'm finding volume, length, width, and height. So we have our L, we have our W. How much is the H? The H is how much? What's the H? Listen, I don't want you to stand there, wait. So you're coming over here. So how much is my height? Is my height the length? Is my height the width? Is my height the cutout? How much is the height? How much is the flap folding up? The cutout. So the H is the cutout. H is the cutout. Is this good, Nadia? Is this kind of what you needed? Okay. All right, which one am I forgetting? Uniform, corner. Oh, Pythagorean? What is that what you said? That's right. Okay, so number 5, can I flip or are you guys still writing on that one? All right, so number 5 is Pythagorean. So that one's kind of easy because that one you kind of get a triangle. Pythagorean. So you have a triangle and you're going to use a squared plus b squared is c squared. Can I peek at this? Oh, if I forget anything. So I did corner, I did uniform, I did Pythagorean. Oh, we didn't do the 3 sides one. We didn't do the 3 sides. All right, so number 6, 3 sides. 3 sides. So that one usually involves perimeter and area, right? That one usually involves both of them. So as soon as it says I've got fencing, right? That's kind of the one that is the fencing type. You automatically draw a river or a house or whatever, and you draw a rectangle. So which one is better to put the X on in my picture? The vertical one or the horizontal ones? The 2 vertical because they're the same. So X, X, right? Whichever one's the same. And then for the other side, what you have, the amount of fence that you have, minus what you used, and usually what you used is 2x, right? The left and the right. So what you have minus what you used. Again, it's usually area. So area equals length times width. So those are all the ones that we've done so far. Okay, those are all the ones that we've done so far. So today we're adding 2 more. What's the matter? Which one? You know what number? 4. All right, so Hannah wants me to go back to 4 for a second. All right, so what are we on? Number 7, right? All right, so number 7, yep. Yep, I will in 1 second, yep. So number 7 is going to be an economics one. You good? All right, number 7 is an economics one. Which one do you need, Cody, 5 or 6? 6. Whoops. So again, quiz is notes, no packet. Yes, sir. I'm going to talk about it in a second. Right? All right, so number 7. Number 7 is our economics one. What the economic one is going to be about? It's always going to be about like best quantity sold for best profit or revenue or something like that. So the economics one is going to be best quantity for best profit. So you're always going to have, right? You're always going to have 2 parentheses, 2 sets of parentheses. You're going to usually have a price parenthesis and an item parenthesis. You're going to be given a starting price and a starting number of items. Starting price, starting number of items. Then in both of these second parts, this is going to be where your variable is going to be. So if it increases, you're going to add something with X in it. If it decreases, it subtracts something with X in it. It disturbs me when it changes colors when I write. So both of those places are going to have an add or a subtract. Usually there's one of each. Usually one of them's an add and one of them's a subtract. And again, this is the first one we will start with. Mm-hmm. It depends on the problem. So it is going to be like, like the one that we're going to do is apartments. When they increase the price, the number of apartments that they rent decrease. Does that make sense, Will? Right? That if I raise something, not as many people are going to live there, maybe, right? They maybe go find another place to live. So one thing usually increases while the other decreases. Okay. All right, last type, number 8. Again, I kind of wanted to get this in the middle of the 2 types, right? So number 8. Number 8 is projectile motion. Projectile motion. It's physics, right? So physics, sometimes you use meters, right? What is it, like -1/2 GT, something like that? We're going to always use feet. So we're going to have a general formula. General formula. And it usually is h of t equals -16t squared plus vt plus, I'm going to say s here. I use an h in the next one, but I'm going to say s there. Okay, -16 is a constant due to gravity. So it's always -16. So this is like throwing a ball, shooting an arrow. Hannah, if I throw a ball, shoot an arrow, take a guess. What does T stand for? So when I throw a ball, what's happening when I throw a ball? What happens as the ball is being thrown? Say it again. Okay, so good trajectory. You're getting a T, right? But what two variables happen? What two variables happen? Time and distance. So T is our time, right? T is our time, and H of T is our height or our distance. Will and Lloyd, were you going to say the same thing? Were you going to say time? Okay. So then what's the F and the S? I'm sorry, not the F. What's the V and the S? What's V going to stand for when I'm throwing something? The speed, velocity, right? So I'm just going to say velocity instead of speed, just so it's a V. And S, right? Because I don't want you to think S is speed. Anybody know what that constant is? What happens when I throw a ball from here versus if I was taller from here? What's changing? The arc does change. Yeah. The starting point, the y-intercept. I like how he said y-intercept, right? So this is the starting height. Starting height, and I'm going to put y-intercept there. All right, so we're going to do a couple of things on this one, right? So we're going to have little bullets on this one. We're going to ask when it hits the ground, when you're at a certain height, and what's the maximum height, and when does it happen? So we're going to do 3 things in that one. So you have to know what to do in each part. So when you're looking at when it hits the ground, H of T is going to be 0. H of T is going to be 0. When you're looking for a certain height, you are going to take that certain height and plug it into H of T. So to me, these two things are kind of the same thing. When it hits the ground, it's 0. When it's at a certain height, I want to know when it's 100 feet or 50 feet, right? You're going to plug that certain height into H of T. So for those two, you want your equation to be 0, and you're going to either factor it, complete the square, or quadratic formula. Honestly, you're probably never going to complete the square. You're probably going to factor a quadratic formula. Anyone able to tell me what we're going to do, right? So if you think of a ball being thrown, Lloyd said y-intercept, right? What do I have to find for the max height and how it's going to get there? If that's my picture, what do I got to find? H or K, which is the vertex. Yeah. So I need to find the vertex. Very good. So you are going to take standard form, which is ax squared plus bx plus c, and you're going to change to vertex form, which is y equals a x minus h all squared plus k. You're going to remember h is negative b over 2a, and k, you plug h into standard form. All right. So to me, those 8 types, That's really what you want in your notes, right? That's going to tell you how to do every single problem. So if you find, like when you're doing these and when you're doing review ones, if you find something helpful, you go put it right inside those types. So we're only going to do 2 problems today, and then you're going to have 4 problems for homework, and you're going to try to model what we're doing today off of that homework. Remember, the problems that we model, you want in your notes so that you can use them in your assessment. So now Cody just asked when the quiz is. Right now, it is scheduled for Wednesday, okay, right now. But this is kind of what I have planned, right? Whoops, I wanted that one to still be up there. Right, so this is what your quiz is going to look like. You're going to have 10 problems, and there's 2 on each page. All right, because I already made your quiz. Each student is responsible for 5 problems. Each student is only graded on the 5 problems that they complete. If you want to be solo, then you can pick 1 problem per page, right? If you want to be solo. Give me 1 second. Oh, okay. If you want to be a partner, you're still going to pick 1 problem per page, but only 1 problem can be the same. So let's say Sophia and Hannah are partners. So they read all of them. They're like, oh, this page 5 and 6, this is hard. I really only know how to do 6. So they both pick number 6. So then on all the other pages, Sophia, Hannah, Sophia, Hannah, Hannah, Sophia, Sophia, Hannah. They got to do all separate problems. All right? So everybody has notes. The benefit of being solo, you can pick the easiest problem on each page that you think is easiest, right? Benefit of a partner is that you have someone there to ask questions to, right? But hindrance of a partner is you only have 1 page that you can do the same problem on. Okay, so you might be forced to do a harder problem. Hi. What's wrong with that? Yeah, 1 problem per page. It's like, because 1 and 2 are similar. So it's not like you're going to do number 1, 2, 3, 4, and 5, because 1 and 2 are similar, 3 and 4 are similar, but they're all different types. Okay? All right. Massimo, why do you have your phone out? Put it away. Put it away. All right, we ready to do our last 2? Right? Number 6. All right, give Hannah 1 second to look at number 6. All right, so we are first going to do the economics one first, right? The other class liked that one better, and there were less parts, so that one's going to be shorter. Okay, so we're going to do the economics one first. All right, so let's do this one. So remember, you might want to write a little blurb on this one. So this is our economics one. So you don't need to write the whole thing, right? It says a club is arranging a charter flight to Boston. The cost of the trip, right? So here are my 2 things. Cost is the money one. Number of passengers. Number of passengers. So those are going to be my 2 parentheses. So the starting part. The cost of the trip is $150 to start. And when it's $150, 60 people end up going. So that's my start. So now it says, you're going to get back with a refund $2 per passenger when it goes more than 60. So every time I add one person, right? Every time I add one person, you get, so the cost, right, is going to decrease by $2. Does that make sense in the way I set it up? Right? Where's the variable in here? Where should I be putting X? Right? After the black numbers. Very good, right? Because I can have more than one person add. That means I'm going to get $2 every single time. Those are your parentheses. So again, money, item, money, item. So I'm just going to write it a little cleaner so I have room. So 150 minus 2x is going to be 60 plus x. So now I got to decide what I'm going to do with that. So I'm going to read the rest of it. How many passengers must take the flight to produce a revenue of 8,800? How many passengers must take the flight to produce a revenue of 88? Well, isn't the revenue going to be when I multiply these two together, right? And it's going to equal 8,800. Sometimes it might ask me to get the maximum. So I would have to get maximum for this. All right, Graham, what are we doing to solve it? Yeah, you guys back focused here. Somebody help Graham. What do we have to do on the left-hand side? We have to FOIL it, right? So this is where you want your calculator because some of these numbers are going to be big. So if I FOIL it, 150 times 60. Again, if you guys can check my numbers too, because I made mistakes earlier today. So 150 times 60, 9,000. 150 times x. 150x. Negative 2 times 60. Negative 120x. Negative 2x times x, negative 2x squared. All right, yep. Say it again. Okay, let me call and see if she's available, okay? What's our goal in all of these? What do we always need, like equals what? 0, right? So on this left-hand side, right, on this left-hand side, I can combine these two, right? Combine those two, and then I need a 0. So, well, I can bring the 8,800 over there, right? So if I bring the 8,800 over there, I've got 200 plus 30x minus 2x squared. I'll call in 1 second. Whoa. All right, I don't like the way that's situated though. Trent, which one usually comes first? The constant, power of 1, or power of 2? Power of 2. So I just kind of want to flip everything around, right? I'm going to flip everything around. Can I make those numbers lower? Can I make those numbers lower? Divide by what? 2, even better? Negative 2. So divide by negative 2. She said it's a quarter of, just kind of wait until you go. Okay, so we're dividing by negative 2. All right, so divide by negative 2, we get x squared minus 15x, what, minus 100? So even though all that work was so messy, right, that's not bad. Those aren't bad numbers. Quadratic formula or factor? Factor is easy in this one. Factor is easy. Factor is easy. How does it factor, guys? Use your little box if you need it. Factors of 100 to give you negative 15. What numbers multiply? Oh, yeah. What numbers multiply by 100? Cody, give me one. Multiply it to get to 100. 10 and 10, right? That doesn't get us to 15 when we add or subtract. I want another one. Give me another one. I'll do the easy one. 1 and 100. Nope, doesn't add or subtract to get to 15. 2 and 50. Doesn't add or subtract to get to 15. Need another one. Say it again. 4 and 25. Doesn't add or subtract to get it. 5 and 20. 5 and 20. Right? So x, 5, 20. I need a negative 15. So I need negative 20, positive 5. So I need a negative 20 and a positive 5. So x plus 5, x minus 20. Caroline, what happens when I have those two parentheses equaling 0? What do I do to each parenthesis? Set it equal to what? Set it equal to 0 and solve. So I go x plus 5 equals 20. 0. X minus 20 equals 0. So x is negative 5. X is positive 20. So I'm just circling them. We have to answer the question asked. Answer the question asked. All right, so I solved it and I got negative 5 and positive 20, right? Negative 5, positive, and 20. Maxwell, come on. I got negative 5 and positive 20. What is the question being asked? Good. How many passengers? Right? How many passengers? So which parenthesis is passenger? Left or right? Right, right? So my x was negative 5 or 20. Negative 5 or 20. We might have to plug it into both of them to see what happens, right? So if I plug in negative 5 and 20, I don't know, we might have to plug into both, see what happens. I forget the answer on this one. So if I go 60 minus 5 times 1, that's 55. If I go over here, 150 minus 2 times negative 5, that's 160. So if my cost is 160, I have 55 passengers going. So now if I plug in 20, right? If I plug in 20, 60 plus 1 times 20 is 80 passengers. This is a bus, right? Yeah. 150 minus 2 times 20 is 110. So two situations would work. If only 55 people go, they're each going to pay 160 bucks and 800 is collected. If 80 people go, guys, come on. If 80 people go, they're each paying 110 bucks. They're still getting 8,800 for revenue. So either of these answers work. 55 passengers or 80 passengers. They would both be okay. Both be okay. Say it again. Oh, yeah. Guys, we got one more problem. You guys are like chatty today. Stop chatty. I think that one's the easiest problem. Nadia, I'm recording this too, so, okay. I think that one's the easiest. Massimo's not agreeing with me there because he's talking too much. That's what this whole, but you have to just like be okay. I can do this word problem if I stop and read it. Because you guys just want to take these numbers and plug them in everywhere. All right, can we do the last one? Last one. Which one do I want to do? I think I want to do this one. There we go. Now it looks better. All right, so this one's our last one. This one's projectile. I am trying to bribe you guys with notes for your quiz. I have no problem in saying that. I'm trying to encourage you to take these notes. All right, we ready? Projectile. So we are given the formula -16 t squared plus vt plus s. I just called the h in this one. Initial height, velocity, right? -16 is a constant. Yes, but like 2 types might be on one page. So one person might have to do projectile where another person has to do area. So yes, they are all on there, but you might, because you're only doing 5 and we got 8 types. So, all right. So these 5 parts, right, aren't always going to be in this same order. So that's why, and I'll go back to that in a second. That's why when I wrote these notes, right, we're hitting the ground, we're getting a certain height, we're going to a max height, right? That's kind of why I wrote them there. The first thing that you always want to do is write an equation. So the equation is nice. All we have to do is plug it in. So it says, an object is thrown at 40 feet per second. Is that a certain height? Is that time? Is that velocity? Or is that starting height? 40 feet per second. Velocity. So that's velocity. So I'm going to plug that into v sub 0. The little 0, it's like when you do physics, it's actually called velocity naught or height naught, and it means starting velocity. So like this little 0 means time being 0, height being 0. I shouldn't say that. Time being 0, what's the height? So it's just starting. All right, so then, Lloyd, where am I going to put initial height of 4? 4 for the h. That's our starting height. All right, so this is our formula that we're going to use for the whole thing. Oh my God. Oh my God. You're so like off today. You're usually not off. Friday, last period. All right, part B. Part B. All right, Massimo, you're going to tell me what we're doing on all of these. Part B. How long does it take to hit the ground? What am I plugging in where? We just did the notes for it.
Let me check.
How long does it take to hit the ground? Think about it. Hitting the ground. Hitting the ground. Is time being 0? 0 where? In time or height? Hit the ground. Isn't the height 0? H of t is 0. So H of t is 0. Right? So we're going to go 0 equals -16 t squared 40t plus 4. All right, so what methods do I use? 4 methods. Factor, quadratic formula, complete the square, square root. Can I make those numbers better? Can I divide by anything well? 4. You could do 4 or you could do -4, it doesn't matter. Will told me 4, so I'll do 4. Okay, so 4. So I'm getting 0 equals negative 4t squared plus 10t plus 1. I'll give you a hint. That is usually not factorable. That one is usually not factorable. So use quadratic formula. Cody, what's ABC?
-4 and 1.
Good. So again, you guys are going to check me on the math, right? Because I want to make sure I'm not giving you a bad number. So quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. Sophia, am I going to give you that formula? Why? And you have your notes, right? So write it right there. It will be in the right spot, right? So I'm going to get x equals negative b plus or minus b squared minus 4ac all over 2a. You guys always mess up under the radical. Always, always, always. Right? Always, always, always. So look, 2 negatives right here. Make a positive. So you're going to get negative 10 plus or minus 100 plus 16. 116 over negative 8. Remember, these are nice. You're going to use decimals. Negative 10 plus square root of 116 divided by negative 8. I get negative 0.096. Negative 10 minus square root of 116 divided by negative 8. I get 2.596. What do those x's represent? Do they represent a time or a height? Time or height? Time, right? So which one doesn't make sense for time? Negative. So only answer at 2.6 seconds, it was on the ground. 2.6 seconds. All right, I'm going to keep on drawing a picture while I'm doing this too. Right, so I started at 4 and I hit the ground at 2.6. All right, when is the height 20? Trent, where's 20 going? So I'm doing part B. Is 20 a time or a height? A height. So on this one, h of t is 20. So 20 equals negative 16t squared plus 40t plus 4. Sophia, what am I going to do with that 20? Move it to the other side, get me my 0. So what, minus 16? Can I make my numbers lower? Divide by what? Ooh, I can divide by something nice. Even better than 4. Nope, not 6. 8. I can divide by 8. And you know what? When this guy's negative, divide by a negative 8. Right? We could have done it up there too, but this time I want to divide by negative 8 because it's going to be nice. 2t squared minus 5t plus 2. Why is dividing by negative 8 nice? Quadratic formula or factor? This one's a nice one to factor. We are running out of time, so I'm going to factor quickly. If you guys did the little box, don't close up though yet. Don't close up. Right? Because we got to still do D and E a little bit. I'm running on batteries today. All right, so let me ask you a question. Does it make sense that I have 2 answers? A half a second and 2 seconds. Right? A half a second and 2 seconds. My picture went up there. Right? So let me ask you a question. Why does it make sense that it went to 20 feet when I went to a half second and 2 seconds. So on its way up and on its way down, right? All right, I'm going to explain the last part, but we can always pick this up on Monday, right? If I want to get the max height and the time it took to get there, you have to put it in vertex form. Guys, write this last thing down. Come on, you have such good notes right now. Write this last thing down. I still got 3 minutes. Maybe 2 now. All right, so you're going to remember, when does the object reach max height? That's h equals negative b over 2a. So that's your vertex. What is the max height? That's your k. We're plugging h in. We're plugging h in. Again, this is recorded, so you can go back and watch it. But again, these notes, so important, right? You can use them on your quiz. So whenever we come back next, Tuesday, we'll make sure we go back, fill these in, right? And your quiz is either Wednesday or Thursday. If you didn't get to do some notes today, or even our absent people, right? Again, I recorded it. Make sure you're watching it. Thank you for putting chairs up.